Geometry section 1.5. Just a little bit of notes here. We want you to know that the word congruent means equal measure. We have a symbol for this. It just looks like the equal sign with a little squiggle up above it. I believe that is called a tilde. So we have a symbol for that. It's used much the same as equals. In fact, I've given you an example here. Now, the notation here might not make sense to you right away because we haven't talked about how we name angles, but we do name angles sometimes with 3 letters. This says the measure of angle ABC, and this says the measure of angle MNO. The little m means measure. And what I'm saying is those measures are equal. Okay, so for example, if angle ABC has a measure of exactly 84 degrees, then you would know that the measure of angle MNO is also exactly 84 degrees. And the point to this is not about that. Again, we're going to talk about the way we name angles, and we're going to be measuring angles in a different section too. But the point to that right now is that you know that the symbol congruent means that they have equal measure, as it says up here. So angle ABC is congruent to angle MNO, means that their measures are equal. Okay, we will be over the next couple chapters kind of moving away from what you're probably more familiar with, which is the symbol equals, and more into congruence. And we'll be full on to that in chapter 4 when we're writing proofs. It'll pretty much all be about congruence. So start to get used to the word, start to get used to the symbol. We like this notation in geometry. That last thing there, the midpoint, we'll talk about that when I come back after we've done a couple of examples. So let's look at an example here that says, find which 2 of the segments, segment XY, segment ZY, and segment ZW are congruent. So as I look here, I see segment XY is right there. I see segment ZY is right here, and I see segment ZW is right here. Very clearly, segment XY, this one, and segment ZW are the congruent ones. And it's as simple as counting on a number line. Yes, we started with a very simple problem. It's 1, 2, 3, 4. This one is 1, 2, 3, 4 units on a number line, where this is just only 1, 2, 3. So XY and ZW are the congruent segments. And you should use the segment symbol like they did there. And when you say it, you should say the word segment. Segment XY, but we could say it this way, right? They're congruent. Segment XY is congruent to segment ZW. Okay? By the way, just to throw this in there too, there is such a thing as not congruent to. Just like you have not equals, you put a slash through an equals, they're not congruent to segment ZY. Okay? That was just a warm-up problem, really. This is the kind of problem we really want you to be able to do. Notice that this segment right here, AN, is clearly a different length than NB. Now, you never trust a picture in geometry. You never can just trust that we've drawn a picture to scale. But this is on purpose, that one segment is clearly smaller than the other. And notice in the problem it says that AB is equal to 25. Now, yet another thing, you notice that there's no symbol above AB. You've been seeing segments in there with symbols. The lack of a symbol means length, okay? So when I say, hey, look at AB, when I say look at segment AB, that's this whole segment here. But that doesn't speak of its length. That's speaking of its name. Therefore, I would use the segment symbol. When I tell you that it's 25, we leave the symbol off, right? No segment symbol, no line symbol, no ray symbol. When it's no symbol, when there's nothing above there, it's length. So here's the thing. AN, the length, plus NB, the length, would be equal to the length of AB, okay? Now, that's important for us. That'll be more important for us in Chapter 2. I wanted to introduce it to you now. And some point at Chapter 2, I'm going to point back at this day. So you don't really need to know the segment addition postulate right now. But at some point in Chapter 2, I'm going to point back at this lesson right here, this video, and say, remember when I told you about the segment addition postulate, right? Now, for the purposes of this problem, what we want to do is we want to replace AN with 2x minus 6. And replace NB with x plus 7. And replace AB with 25. Now, what does it mean? I'm using the word replace, but what word do we have in math for replace? That's substitution. So we're substituting here. Okay? And on your homework, you don't need to do this right here. I just want to show you what I'm using. Okay, now what do we have? Well, 2x plus x would be 3x. We call this combine like terms. -6 plus 7 would be +1. You could write combine like terms here. Actually, our book calls this just simplify. Again, referencing chapter 2, there's a point in chapter 2 where we will be doing this, because I kind of want to introduce you to it. As you do your homework problems like this, you don't have to do that though. If you subtract 1 from both sides here, this would be like a pre-algebra problem. You'd get 24. If you divide both sides then by 3, 24 divided by 3 is 8. Here we subtracted. This is known as the subtraction property. You can abbreviate to subtraction property of equality. And then we divided to get to here, division property of equality. Okay. Now, I know I've said this twice already, but don't worry about this right now. Kind of just introducing it to you right now. So that's x equals 8. Now, always make sure that you answer the question that they're asking. Did they ask us to find x? Yes, but is that all? They also said then find an and nb. So an, again, no symbol, didn't put a segment symbol up here. The length an is 2x minus 6, which is 2 times 8 minus 6. 16 minus 6 is 10. The length NB is x plus 7. Our x was 8, right? So that's really 8 plus 7, which is 15. And then just as a final check, you want to make sure that those do in fact add up to what we know that segment length is, and it is 25. Okay, so now I know that my answer is right. So you really have 3 parts to this answer. X equals 8, and then AN's length and NB's length. Back to the notes to talk about what a midpoint is. A midpoint divides a segment into 2 congruent segments. It essentially is a point that divides a segment exactly in half. Okay? Now, that's important because of the next problem. And I want you to contrast the final example here with the one that we just did. Here, you took a value, a length that's in algebraic form, an algebraic expression. You added it to another one because we know the total length to be 25. In this problem, you are not given that information, but rather you are told that m is the midpoint of RT. Okay? So there is no add them up and set them equal to a number. In fact, if m is the midpoint, then these 2 segments would be congruent to each other. Okay? Now I could take the tack that I did on the last example, and I could start with RM is congruent to TM, and that would be by definition a midpoint. I'm just going to shorten this up a little bit and finish the problem out. 5x plus 9, though, is equal to 8x minus 36. Most of you, I think, would say subtract 5x from both sides. There's really 4 first steps that would be correct in this example, but most people would say subtract 5x from both sides. So you subtract 5x here, it's gone. If you subtract 5x here, you're going to be left with 3x. Then we want to get the variable by itself. It's being multiplied by 3 and then subtracted by 36. So let's go ahead and add 36, adding 36 to both sides. This is what we have to do with an equation. 9 plus 36 is 45. You're left with just 3x here. And then finally divide both sides by 3. Some people would say multiply by the reciprocal of 3, which is 1/3. Either way, you're going to get 15 here. So x equals 15. I like to flip it around. I always like the variable on the left. So x equals 15. Now let's test that out too. Rm is equal to 5x plus 9. 5 times 15 plus 9. That would be 84. MT is equal to 8x, 8 times 15, minus 36. Well, 8 times 15 is 120, minus 36 is 84. If you need to use your calculator, there's no shame in that. Okay. Hey, they did ask us for one more thing. They did ask us for RT as well. That's the total length of this thing. So RT would be equal to 84 plus 84, which is 168. Or 84 times 2, which is 168. And again, there's kind of a built-in check in that in that you got 84 for both of these. I wouldn't, especially on a quiz or a test, I wouldn't just find one of them and then just assume 84 for the other one if we gave you a problem like this. No, do it honestly, check them both, and then when they come out to the same thing, you know you're right. All right, that's it for the lesson. Thanks for tuning in.